So what are attributes anyway? Well, they're just data that's stored within either an instance or the class itself. And how do we access them? Well, we can use dot expressions, or there's a built-in function that does the same thing. So going back to our account example, I could create an account by calling the account class, and I can access the balance on that account with john.balance. There's also a built-in function called getAttr, that's getAttribute, where you pass in an object and the name of the attribute that you want to get, and you'll get that balance back. And this works even if we've deposited some money. We can also check and see if an object has a particular attribute. So we have a balance, but we don't have a lance, for instance. So accessing an attribute, we can use a dot expression, or we can use getAttr. And that allows us to look up an attribute using a string. So we looked at that example, and we can also check whether an object has an attribute. GetAttr and dot expressions are exactly the same thing. It's just a functional form of a specialized syntax. They look up the name in exactly the same way. And looking up an attribute may return either an instance attribute or an attribute of the class. But basically, you look in the instance first. If it's there, then that's the attribute that you get. Otherwise, you look in the class. Okay. So let's talk about methods and functions. Well, a method is an attribute that's a function. So Python distinguishes between two things. Functions, which have been around since the beginning of this course. We know all about those. And bound methods, which couple together a function and the object on which the method will be invoked. So what does that mean? Well, when I have an object and a function, and that object is going to be passed in as the first argument to that function. The function is a method. Then that's called a bound method. So let's take a look. If I look up the attribute deposit on the account class, all it is a function. And it's something that takes two arguments. It takes the object that I'm depositing into and then the amount that I want to deposit. If instead I look up deposit on an instance of the account class, where TomAccount is an account, then what I see is that this is a method, which means it's taken the deposit function and bound it together with the TomAccount, which will be passed in as the first argument when we actually call the function. Okay, so what happens? Well, if we access the function directly from the class, then we need to pass in two arguments. Because remember how it was defined. It took two arguments. One was called self, and the other was called amount. So if I take in TomAccount and I pass in 1001, now there's $1,011 in the account. On the other hand, if I start out with TomAccount and I look up the attribute deposit, what I get back is a method. A method is different than a function in the sense that the first argument is already filled in with TomAccount. So TomAccount is already the first argument, and all we need to do is supply the second argument, 1000. So let's talk about looking up attributes by name. We see a dot expression. In order to evaluate a dot expression, we evaluate the expression to the left of the dot, which yields the object of the dot expression. That's where we're going to look up the name. Then, name is matched against the instance attributes of that object. If an attribute with that name exists, its value is returned. If not, then name is looked up in the class, which yields a class attribute value. That value is returned unless it's a function, like withdraw or deposit, in which case a bound method is returned instead, where what's bound together Well, the object of the dot expression is bound together with that function to create a bound method. So, there are attributes of an instance and there are attributes of a class. So far, all the attributes of the class we've seen have been methods. But that's not the only option we have. Class attributes are anything that's shared across all instances of a class, because they're part of the class, not part of the instance. Now it happens to be that when you look up that attribute by name on an instance, and it's not on the instance, you'll find it in the class. Okay, so let's extend our example a little bit. Here's our account class. In addition to defining the constructor, we're also going to add a class attribute called interest, the interest rate. Now this is something that will be shared among all accounts. So all accounts have the same interest rate. If I look up interest on an account, I'll find 0.02 as the value. So here I create a new account. Tom is the holder. Jim is the holder of a second account. And what's the interest rate for Tom account? It's 0.02. And what about for Jim? Same thing. Because they both are instances of this class, neither of them has its own interest, but the class has an interest rate, and that's what we're looking up in these two cases. So it's important to note that interest is not copied into each instance. Instead, it's always kept in the class. And that's important because if it changes in the class, well, that change will be reflected in all of the instances.